So, our own Allan Federman is going to be talking about this book, Arduino Robotics, and I'll let him do the rest of the talking.
Okay, thanks.
What's the first rule of HBRC? Never volunteer. Okay. All right. So actually, I got this out of the library, and usually when I get one of these self-help books from the library, oh, they're pretty poor. But this one's actually quite good, and it's really good, I think, if you're a novice, never touched a robot before, because it goes through everything. The authors are all associated with the University of Alabama, Birmingham, and these guys are builders. This guy has built basically the equivalent of a Robo Magellan, a Segway, a boat, basically a ClubBot, a line follower, and it goes in order. So, and there are very few typos. There was one major typo. The first typo I started scanning, the first chapter, they had two chapters, one, and obviously it was a different editor because the first chapter one was the Oracle Apex system, which I didn't find any reference to that in the book. So order-wise, as far as the basics, he goes through basic electricity, Ohm's law. We'll talk a little bit more about that. And then he starts talking about the Arduino. And I don't know, have we ever had an Arduino talk here? It's a fairly popular processor.
I think there was one talk when I couldn't make the meeting.
Okay. So, I don't remember ever seeing the Arduino, and then all of a sudden they just started showing up. So they're pretty popular, and what's popular, what's cool here is the Google ADK is based on the Arduino Mega. And the Arduino comes in lots and lots of different packages. So certainly useful, and I'm going to pass one around. This is a busted one, so I can pass it around. So Tech Shop also teaches this, and they also have since Tech Shop pays me, I have to say that, but they actually have a very good course progression if you're brand new, who starts off with soldering, teaching people how to solder. You've never soldered before. It's a skill. It helps if someone shows you how to do it the first time. And if you get a little instruction, it works much better. Then the next progression is we actually build that board. That's a kit board, and people actually build their own board. Then the next course after that is they start the program. So as far as his chapters go, in the Let's Get Moving, he talks a lot about motors and controlling motors. And I mean, there were some details in there. And then he goes through these various other boats. The Explorer Bot and the Lawn Bot are fairly big robots. He designs his own H-bridges. There's also a website in the book, so not only can you download the codes, you can actually download the PCB masks. He tells you how to make PCB boards. He has a fairly interesting technique for using it. I think should be, and there are a lot of cool details in it. So looking at the the chapter in detail, goes through basically all the knowledge that you need is in there. So and there may be some misspellings here because before I realized I could download the chapters, I sort of scanned it in with OCR. So I just want to go through the detail as far as how he discusses every possible type of motor. Plus, I thought was really interesting is he has a discussion of back EMF, which if you were just starting the first time, you wouldn't realize that if you have something like a coil or a solenoid that's controlling a motor, when you turn it off, there's back EMF. You get a spike back into your process and burn out your electronics. So he even has even explains that concept and has the diagram where you put the diode to block the back EMF. And then, you know, a couple of designs. And so basically, this would be the equivalent of, I guess, a MicroMouse, a MiniMouse, or a ClubBot, where he's using 2 servos to drive the motors. He has 2 recipes for converting servos to continuous rotation. I knew one of them, I didn't know the other one. Apparently, if you just take off the stop, if you pulse it at a low pulse rate, it goes clockwise, and you pulse it at a high, it goes counterclockwise. I didn't know you could do that. But, so there's a little interesting detail, so I picked up some useful information. And then, you know, some of the robots are fairly sophisticated, so he has his own Segway clone that he actually designed the inertial sensors to check the balance and run it. I don't know. I haven't seen a video of this running or not, but I assume it can go pretty well. And then talk about hardware and software, and I'll demonstrate some of these, I hope. So this is the one we use at Tech Shop. I guess it's a Arduino bare bones board. So they basically break out the USB components. Most of the boards that you see, if you go to the Arduino site, they basically put these components on the board, but these are surface mount, and this you can all build by hand soldering. There's only one little surface mount component on it. It's a sort of useful exercise. You can actually experiment with doing one little surface mount. I think it's a diode that could surface mount on the board. It's coming around. The ADK, let's see, this to work. This is getting the power from the USB, and this is so this is the Google ADK, which is Arduino Mega 2560, and it has both the Arduino and then it has a breakout board with colored diodes. I'll show you the sketches that run some of these things in a minute. I call this one traffic light. It's just going through and doing the colors on the tricolor LEDs. Yeah, I'm sorry.
Do you experiment with controlling your ADK with the Android?
I had a problem in that the Android device I have is that Color Nook that I sourced Android on, and I can't get the USB portion of Eclipse to load the demo kit onto it. It says you have the wrong something USB. So I'm going to check out the microbridge. The reason why I sourced Android on a Color Nook is I have no money and I couldn't afford paying the $40 extra a month to get an Android phone. But now apparently I hear you can get $40 Android phones. And if I had some ham, I'd have some ham and eggs. If I had some eggs. But, you know. So actually, no, that Android tablet, and I'm sorry I can demonstrate it, except it ran out of battery. I actually got the ROS app chooser to run, and we were running Willy around with it.
I saw it.
Yeah, and actually I have a video of it. So, see, I don't always trust that these things will actually work. So, okay, so. So I have these links for movies, but the last time I tried to run a movie from here, it crashed everything, so I won't. But what's really useful is, and I'll put this whole presentation up on the website, but basically you can go and actually get the sketches. So here's his H-bridge PCB layout. That's on Chapter 8. So that was for a fairly hefty, I think he was using 80 amp MOSFETs. So that's for a fairly powerful electric motor. I think the robot was his lawnmower robot. I think it's Chapter 8 is Explorer Bot. It's a huge cast iron frame thing. Be good for Robo Magellan or BattleBots. You know, it's probably around a 50, 60 pound robot at least. And he does use GPS, so he uses, I saw some club email about the Arduino pilot, I don't know if that's pronounced right, which is interfacing it to a GPS. So he has a number of projects where he uses GPS. He has a boat, he has an outdoor explorer that uses GPS. Talks about interference. So this is a simple sketch, which is, I don't know that technically if it's that different from C or C++. Someone who's a real software engineer can explain. Is it C? It's C. And since it has voids in it, it's, it may be C++. So this is that sketch running on this. So it's a pretty good set for experimenting because you have all the pins exposed and you can interface it pretty easily. And this is an LED, a resistor, and a wire to get light. And it just is fairly simple. Typically it comes default, it's pin 13. I changed this to pin 9. And if you look, you see the resistor, the diode, the LED is plugged into pin 9. Okay, for all you young people, diode has two legs, a long leg, light emitting diode has a long leg and a short leg. Which leg goes to positive?
Short.
No!
No?
The long leg goes to positive.
The long leg is the anode?
The long leg goes to positive. No wonder none of your things work.
No. The long leg is the cathode. The short leg is the anode.
Google it.
Look at your
What?
LED.
Long leg goes to positive.
The long leg goes to plus.
Yes.
The same thing on a capacitor. If you have a
Depends on if you
capacitor.
want to forward or reverse bias it.
All right, we're going to have.
We're going to fight it out.
We're going to fight it out. Cage fight. Okay, do you want me to plug this diode in the reverse way and see what happens?
I'm just saying.
If you plug it in the wrong way, you let the magic ray smoke out. And once you let the magic ray smoke out, it doesn't work anymore.
If you run enough current, you can turn a green LED orange.
Yeah, for just a little bit, and then it goes
It
black.
actually will be orange for quite a while.
Oh. You have to take my soldering class.
No, the long leg is the cathode.
That's right, look for the flat. The flat should be on the long leg side.
And which polarity you plug it into is depending on what it is you're trying to do.
Make it light.
Well,
Make it
maybe
blink.
I want a dark emitting diode.
Okay, I didn't think I'd have a problem with that part. All right, so the other thing that's cool is I saw Fergie come in, right? Fergie's here. Mr. Ferguson has been working on something called the Ross Serial Bridge, and it works with Arduino. So this is a sketch that I wrote that works with Ross and with my Mega. And we have a couple of relay ports out here, analog out ports. And we also can include some libraries so we can actually tie it into the robot operating system. So this is a fairly simple sketch that toggles two relays on and then turns them off. So I call this program forward. So that's all it does. It turns on two motors on in the positive direction, so the robot goes forward. Then when you toggle it again, the robot goes off. And that's it. Any questions? Oh, he Googled it. Well, it's a good place to Google things.
I will comment that the ClubBot uses Arduinos as the base processor. So,
Dude, this is LEDs.
the long light's positive, I know that much.
No, sometimes.
Alan, I was wrong. The long leg is the anode.
So will you come up here and do homage? I think, well, you're going to have to get down on one.
I'm just trying to keep it straight.
Any further questions?
Oh, yeah. Is that book download there? Is that the whole book you download, or is that just like the
No, that's
PCB
just
stuff?
That's just the sketches. It's not the whole book.
The whole book is this.
Yeah,
Okay.
and I get no kickbacks from the authors. It's $40, but it has everything.
And you can frequently get books like this from the library.
Yeah, this is where I got mine.
So, you know, a lot of people have forgotten that the library exists. Okay, anything else?
Alan,
Yes, sir.
have you built any of those projects in the book?
Not any of the projects in the book, but I'm looking at some of his H-bridge
Do
designs.
you know anyone out here who has? Not yet.
Not yet.
That's why he's talking about the book. Encourage people.
When was that published? I mean, how many?
It's fairly recent. I think it's it'll say, I think it's 2011. It looks new.
Okay. So,